Bismillahirrahmanirrahim. Assalamu alaikum everyone. I am Dr. Ahmed Rehoumy, a lecturer at Civil Engineering Department in the Faculty of Engineering, University of Anbar. This is lecture talking about the wastewater treatment technologies. We were talking about the conventional wastewater treatment technologies, and we will focusing on the biological treatment. First of all, we will define what is the meaning of wastewater. Wastewater is a used water that could be used for purposes of domestic, commercial, industrial, etc. And it has physical, chemical, and biological impurities. These impurities could be measured in the wastewater, and these pollutants could be summarized in this slide. We could see that measuring of BOD, that is related with the oxygen content. It's called, this definition BOD, it's abbreviation of biochemical oxygen demand. And another parameter, it is COD, for measuring the contaminants in the wastewater. And it is abbreviation of chemical oxygen demand. And also DO, it is dissolved oxygen. It is also another parameters, could be used for check if the water has a sufficient dissolved oxygen or not. Another contaminants, it is solid contents, such as total solid, it is TS, or total suspended solids, TDS, and total volatile solids. Nutrients also, it is one of the contaminants. The main compounds, or the main compounds in the nutrients, it is phosphorus and nitrogen. Also acidity, it is one of the pollutants. Acidity, it means pH of the wastewater. And also there is bacteria in the wastewater, such as fecal coliform and temperature. Now, where does wastewater come from? The main sources of wastewater is coming from residential area, maybe coming from bathroom, kitchen, laundry, and etc. Second main source of wastewater is coming from commercial institutions, such as offices, schools, and another governmental institutions. And also we have the third main source of wastewater. It's called industrial wastewater. This kind of wastewater need for special treatment process. Now we coming to define what is the meaning of wastewater treatment. Usually the term of wastewater treatment refer to the sewage treatment or domestic wastewater treatment. What can do by treating the wastewater? The treatment of wastewater, it is a process of removing, reducing, or stabilizing the materials in the wastewater. Or could you, there is another kinds of wastewater could be combined between the rainfall collectors and the domestic wastewater. Why treating wastewater? Why we are treating the wastewater? The main reason for treating wastewater, it is to protect is to reduce the environmental impacts and also protect public health. Because if the wastewater will be not treated, the aquatic life will be in danger. Another reason for treating wastewater, it is for purpose of reuse or recycling wastewater. Recycled wastewater may be recycled wastewater maybe could be used for potable if there is a high or advanced technologies for treatment, or could be used for irrigation purposes, or sometimes it could be used, the recycled wastewater could be used for industrial purposes. And also there is agencies has a regulation should be compiled, should be obeyed, otherwise there is some regulations imposed to find the institution that has affected or not treated their wastewater. These kind of agencies called environmental protection agencies. The treatment of the wastewater could be removed by different processes. It could be removed where? In the wastewater treatment plants. Wastewater treatment plants has a different processes. First of the combination of these processes could be produce a high quality effluents, could be less affected on the environment. These processes, physical processes relating with the sedimentations, flotation, and screening and filtration. Another processes called biological processes, such as trickling filter, RBCs, and activated sludge. This is the most conventional technologies used. Another processes called chemical processes. Chemical, such as chemical precipitation, ozonation, or chlorination. Typical wastewater treatment processes. The typical wastewater treatment processes, it consists of 4 parts. It is preliminary treatment and the primary treatment, third secondary treatment, fourth advanced treatment. We will focusing here in the on the secondary treatment using biological treatment. The preliminary and primary treatment, the objective of these processes is the removal of coarse solids and other large materials. We could see in this figure there is screen at the first step from the left. First step is a screen, other for removing the coarse solids, and after that we'll go to the grit removal or grit chamber. After that we'll go to the primary sedimentation tank or primary clarification. The effluent from primary clarification will go to the secondary treatment. Yes. Primary and preliminary and primary treatments is effective in removing the particulate matter, large or the particle matter that is called larger than 50 microns. And in general, about 50% of the suspended solids and 25 to 50% of the BOD5 are removed from untreated wastewater. About the nutrients, hydrophobic constituents, metals, and microorganisms that are associated with the particulate in wastewater. These contaminants could be removed about 10 to 20% of the organic nitrogen and about 10% of the phosphorus are removed. Secondary treatment. Secondary treatment, the preliminary and the primary treatments alone actually doesn't provide adequate treatment. To meet water quality objectives, in most cases, secondary treatment follows primary treatment is needed for further removal of residual biodegradable dirt and colloidal organics, and also for further removing of suspended solids using aerobic or sometimes anaerobic biological treatment processes. The contaminants or the contents or the compartments of conventional activated sludge biological treatment, it consists of two tanks. One tank is called aeration tank. After aeration tank, the effluent from aeration tank will go to the secondary clarifier. The secondary clarifier, at the secondary clarifier, the supernatant will be discharged for the tertiary treatment, and the sludge will be recycled to the aeration tank, and a part of this recycled sludge will go to the another process is called dewatering or sludge handling. How could the biological treatment works? Microorganisms in the wastewater or in the aeration tank will consume organic matter from the wastewater using oxygen respiration. As we see in this figure, you could see that the microorganisms and the food, it's related to the contaminants. It is like food for these kinds of microorganisms. And in the presence of the oxygen, these kind of microorganisms will degrade the contaminants for the final products of CO2 and water and provide new cells and sometimes ammonia. There is 1 million of aerobic and facultative microorganisms remove pollutant through living and growing processes. Objective of biological treatments. The objective of biological treatments is coagulants and remove the non-suitable colloidal solids. This is the main objective of biological treatment. Stabilize the organic matter, reduce the organic matter, and remove the nutrients. In short essay, stabilizing organic matter, it means convert organic matter to non-biodegradable form so that it doesn't exert oxygen demand. Biological wastewater treatment or major aerobic biological processes could be depending on the type of growth. We have suspended growth system. The common name of this kind of treatment is called activated sludge. It is used for carbonaceous BOD removal and also nitrification. And also we have aerated lagoons. It is under the group of suspended growth system. We have another group called attached growth system. This kind of attached growth systems, the commonly process used here in this kind of process, it is a trickling filter. It is very wide separate technology used for removing of contaminants from wastewater. And also we have a roughing filter, trickling filter with high hydraulic loading rate and rotating biological contactors. And also we have another technique called packed bed reactors. all these kind of technologies used for carbonaceous BOD removal and nitrification. The third group, it is combination between two types of growth. It is combination between suspended and attached growth. It could be merged or could be combined, two processes in one treatment for more removal of carbonaceous BOD and nitrification, such as biofilter and activated sludge, series of trickling filter and activated sludge, etc. What is the activated sludge process? The activated sludge process consists, as we said before, it consists of two compartments. First of them, it's called aeration tank, where is the biological process held on, and the second compartment is called secondary clarifier. This kind is of wastewater. It is suspended. It's depending on the suspended growth system, and mixed liquor are aerated using the devices like air compressor or air diffusers. The types of activated sludge system, it is the most commonly used. It is complete mix reactor and sequencing batch reactor, extended aeration, deep tank, and deep shift. The advantages and the disadvantages of activated sludge could be summarized in this slide. The advantages: it is flexible. This technique is flexible, can adapt to minor pH, organic and temperature changes. Small area required, and degree of nitrification is controllable, and also relatively minor other problem. The disadvantages for this technique: it has high operation cost and need for a skilled labor and electricity and etc. Generate solids required sludge disposal, because the sludge production it is very high. That's why need for sludge disposal, need for equipments for sludge disposal. Some processes, another disadvantage, some process alternatives are sensitive to shock loads and metallic or other poisons. And disadvantage, another disadvantage, requires continuous air supply. Another kind of wastewater technology is called trickling filter. Trickling filter, it is also a reactor using attached growth system for treating wastewater, whereas the microorganisms will grow and attach to the inert media. This inert media may be plastic, maybe could be rock, or could be another supporting material, and the mechanism of removing contaminants in this kind of wastewater treatment plant, depending on the diffusion of the contaminants when the slaughterhouse passing through the media, the attached microbes will be absorb the contaminants and treated the wastewater. The advantages and disadvantages of trickling filter. Advantages: it is good quality. There is removal of BOD 80 to 90%. In some cases, if there is 2 stages, the efficiency will be rising, could be reached to 95% of organic removal. Moderate operating cost, lower than activated sludge, and also withstand. This is another advantage. It is contrary with the activated sludge. it is withstands shock loading cases better than the biological process. The disadvantages, it is high capital cost and also clogging of distributors or beds. Sometimes if there is the contaminants, it is very high in contaminants, the distributors or trickling equipments will be clogged, or sometimes the bed of the rock will be clogged. Snail, mosquito, and insects problems will be appeared in this kind of treatment plants. Another method or another technology for biological treatments, it is called rotating biological contactors. Rotating biological contactor is a kind, or it is a type of attached growth system, but it is aerobic system. It is consists of a series of circular discs of polystyrene or polyvinyl chloride that are submerged in wastewater and rotated slowly through it. We could see from the figures shown in this slide, we could see this kind, the RBC reactor. It is submerged, halfly submerged with wastewater, and another part and another half it is exposed to the air for consuming oxygen. The disc rotated alternately contacts the biomass with the organic material and then with atmosphere for absorption of oxygen. Excess solids are removed by shearing forces created by the rotating mechanism. The advantages and disadvantages of RBCs. Advantages: short contact period, handle a wide range of flow, easily separates biomass from waste stream, and also low operating cost, short retention time, low sludge protection, and also excellent process control. The disadvantage, it has less disadvantage. Need for covering units installed in cold climate to protect against freezing. Need for covering. And also shaft bearings and mechanical drive units require frequent maintenance. Major anaerobic biological treatment. All the examples that we get previously in the previous slides, it is related with the aerobic biological process. Now we are talking about the anaerobic biological processes. This also depends on the kind of growth in the reactor. We have also suspended growth and also we have attached growth. The common reactor for treatment the wastewater anaerobically using suspended growth, it is anaerobic contact process and upflow anaerobic sludge blanket. These two parameters, these two reactors used for removing carbonaceous BOD. And another two types for anaerobic process using attached growth. We have anaerobic filter process and expanded bed. This also used for carbonaceous BOD removal and waste stabilization. Yes. The anaerobic contact process, it is consist of also two vessels. One vessel, it is for treating. It's used for treating wastewater anaerobically. It is fully closed. And the influent or the wastewater will will enter the wastewater tank or the reactor and treated for a certain time. After that, the treated wastewater will go to the clarifier. That clarifier will be settled. Will be settled the sludge and removing the treated wastewater. And the main benefits of this kind of wastewater, it is gas production. Gas production could be used for energy recovery. Now also there is some advantages and disadvantages for this kind of treatment or biological treatment. The advantages related with the methane recovery as energy. A small area required. Volatile solids destruction. Volatile solids will be destruction, and the sludge to be disposed of is minimal. The sludge production it is small quantity. Disadvantages: heat required, and also effluent in reduced chemical form requires further treatment. Requires a skilled operation. Another technique or another technology for anaerobic treatment using suspended growth. It is a very famous reactor called upflow anaerobic sludge blanket, and abbreviation UASB. The wastewater flows upwards through a sludge blanket composed of biological granules that decompose organic matter. Some of the generated gas attached to the granules that rise and strike degassing baffles, releasing the gas produced in this kind of process. Free gas is collected by special domes. The effluent passes into a settling chamber. The advantages and disadvantages of upflow anaerobic sludge blanket could be summarized here in this slide. Low energy demand, low land requirement, low sludge production, less expensive than other anaerobic processes, high organic removal efficiency. And the disadvantages, it could be summarized by long startup period. That means the acclimatization period it is need for a long time, and also requires sufficient amount of granules, seeds, sludge for faster startup, significant washout of sludge during initial phases of process. That means there is a problem of sludge washout because the flow goes from down upward. Lower gas yield than other anaerobic process. The production of gases it is lower than another anaerobic processes. The typical wastewater treatment processes, in summarized, typical wastewater treatment plant processes could be summarized in this slide. Will started with the uplift starting with the coarse screening and through the pumping station. After that, go to the fine screening. After that, the wastewater goes to the grit removal or grit chamber for removing silt and small particles. After that, these treatments at the first row of this slide, the first row of this represents the primary treatment. After that, goes to the secondary treatment. It is aeration tank. We have aeration tank, settling tank, and also we have degassing tank if there is nutrient removal process done. This is the second row of this slide. It is related to the secondary treatment, and after that goes to the chlorination unit at the third row after settlement, after secondary clarifier. The flow will go to the treatment of advanced treatment or tertiary treatment related to the disinfection. The pollution that could be removed, or the pollution removal efficiency, could be summarized in this table by using typical wastewater treatment plan. The parameters, we have 5 parameters: suspended solids, BOD, phosphorus, nitrogen, and E. coli as bacteria. For suspended solids, in the primary treatment, we could remove 50 to 80% of suspended solids. In the secondary treatment, we could remove 80 to 90% of suspended solids. At the tertiary treatment, more than 90% of suspended solids will be removed. For the parameter BOD, in the primary treatment, we could remove 20 to 40% of BOD. In the secondary, we could remove 70 to 90%. And after the tertiary treatment, we could remove more than 90% of BOD. Also for phosphorus, as a nutrient contaminants, at a primary, less than 10%. At secondary, 30%, around 30% will be removed. At tertiary, more than 90% will be removed. For nitrogen compounds, at the primary treatment, less than 10% removal, and at secondary, 30%. After tertiary treatment, 70% will be removed. For E. coli, 1 log of E. coli will be removed, and 2 to 3 log percent will be removed as secondary, and at tertiary 3 to 5 logs. Now we have reached to the final slides, and I hope to meet you again for the second lecture, inshallah. Thank you too much, and thank you for your listening.